Welcome to this video on energetics. Now, in this video, we're going to be discussing key terms in this topic. So let's start off with enthalpy change. So enthalpy change is basically heat transfer at a constant pressure, or in simple terms, the amount of energy transferred in or out of a system while the pressure is constant. Now, in your A-level chemistry course, you're going to encounter two types of reactions, and we're going to discuss them now. So the two types of reaction you're going to incur are exothermic reactions and endothermic reactions. Now, before we carry on talking about heat transfer, I want you to understand that when we talk about heat transfer, we're talking about heat transfer between a system and its surroundings. Now, in an exothermic reaction, energy is transferred from the system to the surroundings. So energy is basically given out. Now I'm going to draw the diagram for an exothermic reaction. So it's important to understand here that in an exothermic reaction, the products have less energy than the reactants. Hence, the enthalpy change is negative because energy is given out. Take an example of a bank account. If you pay money out of a bank account, your balance becomes more negative. Same way, in an exothermic reaction, you give out energy. Therefore, your enthalpy change should be negative. Now, the second type of reaction is endothermic reactions. In an endothermic reaction, energy is transferred from the surroundings to the system. Energy is taken in. And now I'm going to draw the endothermic reaction. So in an endothermic reaction, the products have more energy than the reactants. The enthalpy change is positive. Again, take the example of a bank. So when somebody pays money into your account, the transaction is positive. Same way, in an endothermic reaction, energy is getting taken in, hence your enthalpy change becomes positive. And I wanna touch on this term, activation energy. Now, what is activation energy? Well, we're going to discuss this further, but for now, activation energy is basically the minimum energy required for the reaction to start. So for this exothermic reaction to occur, there has to be some sort of activation energy, which then starts the exothermic reaction. Similarly, in an endothermic reaction, you need some sort of activation energy to get the reagents to a certain energy at which then the reaction can take place. Now, let's move on to standard enthalpy of formation. So before we start, I want to introduce you to a term called standard conditions. Now, standard conditions are going to be used throughout your A-level chemistry course. So I just want to introduce them to you. Now, standard conditions are as follows. So the standard condition is 298 Kelvin, 100 kilopascals, and a solution with a concentration of 1 mole per decimeter cubed. And that's the symbol for standard conditions. So, what is standard enthalpy of formation? Standard enthalpy of formation is when 1 mole of a compound is made or formed from its elements under standard conditions, and the reactants and products are in their standard states. Now, one thing to note is that standard entropy of formation of an element is 0. Now, let's do an example. How would you write the standard entropy of formation of aluminium oxide? So, to write the standard entropy formation of aluminium oxide, remember that you are forming 1 mole. So, on your right hand side, put 1 mole of the compound down. Now, we know that we need aluminium and oxygen. And that's the standard state. So aluminium is a solid, oxygen is gas, aluminium oxide is a solid. Now, looking at the right hand side, we can see we need 2 aluminium and 3 oxygens. So on the left hand side, we can put 2 in front of Al and 3 over 2 in front of O2 to then get the completed balance formula of this. So let's move on to the standard entropy of combustion. Standard entropy of combustion is the enthalpy change when 1 mole of a compound is completely combusted in oxygen under standard conditions. Reactants and products are in standard states. So standard entropy of combustion is when 1 mole of a compound is completely combusted in oxygen under standard conditions, and reactants and products are in standard states. So write the standard entropy of combustion of propane. So remember, it's 1 mole. So write down propane, which has the formula C3H8. And then you know that when you burn a hydrocarbon, you get carbon dioxide and water. So now it's time to balance. So on the left hand side, we can see we have 3 carbons. Hence, on the right hand side, we need to have 3 carbon dioxides. Similarly, on the left hand side, we have 8 hydrogens. Hence, on the right hand side, we need to have 8 hydrogens. So we write a 4 in front of the H2O and a 3 in front of the CO2. Now we can see that if we just add up how many oxygens we have, so we can see we have 3 times 2, 6, plus 4, we have 10 oxygens. Hence, on the left-hand side, we need to have 10 oxygens. How do we do this? By simply putting a 5 in front of the O2. Now, this is a balanced equation. Write down your standard state. So propane is a gas, oxygen is a gas, carbon dioxide a gas, and water a liquid. One thing I forgot to put in here when talking about standard entropy of formation is that 1 mole of a compound is formed from its elements under standard conditions. Always remember that. It's under standard conditions. Now, let's summarize. So, enthalpy change. Energy transferred in or out of a system while pressure is constant. And that's the symbol for enthalpy change. The types of reactions you're going to encounter are exothermic and endothermic reactions. In an exothermic reaction, energy is transferred from the system to the surrounding. Endothermic is the opposite, so from the surrounding to the system. Exothermic, energy is given out, and endothermic, energy is taken in. In an exothermic reaction, products have less energy. In an endothermic, products have more energy. Enthalpy change is negative in the exothermic, whilst in the endothermic, it's positive. So basically, if you just memorize one of these, so if you just memorize exothermic, endothermic is basically the complete opposite. Standard conditions, 298 Kelvin, 100 kilopascals, and a solution of concentration of 1 mole per decimeter cubed. Remember these conditions. Remember that this is the symbol for standard conditions. Standard entropy of formation of an element is always 0. And that's the end of the video.